Now to solve this problem, consider a simple result or a simple lemma that if W is equal to x dot y, if W is concatenation of two strings x and y, then WR is equal to YR dot XR. Consider one example, ABB AB. This is W. Now we can write ABB AB as concatenation of ABB dot AB. This is X, this is Y. So WR is BA BBA. This is WR. This will be BA dot BBA. If you consider BA, it is reverse of AB. This is YR. And if you consider BBA, it is reverse of X. It is XR. So if W is equal to X dot Y, WR is equal to YR dot XR. Now we can generalize this result also, that if W is concatenation of U dot V dot X dot Y, if it is concatenation of four strings, then WR is YR dot XR dot VR dot UR. But in this problem, this result is sufficient. Now we have seen this result. Now if P is prefix of a string W, then we can write W as P dot T. P is prefix of W. Now in this case, WR will be TR dot PR using this result. So if P is prefix of W, then PR will be suffix of WR. So that is our result A. So option A is always correct. On the similar lines, if W is equal to T dot S, then WR is equal to SR dot TR using this result. So if S is suffix of W, then SR is prefix of WR, and that is option D. So let's disprove options B and C. Now to disprove options B and C, consider this example. So WR is equal to BA dot BBA. Now option B says P is suffix of WR. So P means prefix of W, ABB. So whether ABB is suffix of WR? No. So this is not always correct. It may be correct sometimes, but it is not always correct. So option B is wrong. S is prefix of WR. So X dot Y, this is a suffix. Suffix is AB. Whether AB is prefix of WR? No, it is not prefix of WR. AB is not prefix of WR. So option C is also not correct. Option A and D, they are always correct. Now in this problem, we should select prefix P and suffix S independently. To select a prefix, W equal to P dot T, P is the prefix. To select suffix, W equal to T dot S, S is the suffix. To select P and S, it is not necessary to satisfy the condition W equal to P dot S. This is necessary, this is also necessary, this is not mandatory. Now let's disprove the wrong options. Now for option A, if we consider string W ABB AB, then length of W is equal to 5. Now if we select prefix P equal to ABB and then suffix equal to BAB, then length of P plus length of S is equal to 3 plus 3 is equal to 6. So 6 less than length of string 5. This is not correct. 6 is greater than 5. So option A is not always correct. Now to disprove option B, if we select prefix as A, only A, suffix as B, then length of P plus length of S is equal to 1 plus 1 is equal to 2. So 2 greater than length of string 5. This is also not correct. So option B is not always correct. If you consider same example, then length of P plus length of S is 2 and option C says length of P plus length of S is equal to length of the string. So 2 equal to 5. This is also not correct. Option C is also wrong. Now the longest possible prefix is string itself. Longest possible suffix is also string itself. So length of prefix is less than or equal to length of string. Length of suffix also is less than or equal to length of string. If we add these two inequalities, then length of P plus length of S is less than or equal to 2 times length of string. So option D is always correct. Now to solve this problem, we should know this formula. Number of strings in sigma power n is equal to k power n, where k is number of symbols in alphabet. So consider this example. Alphabet contains A, B and C, 3 symbols, and we want to find how many strings are there in sigma power 5. So sigma power 5 means set of all strings of length 5, and we have 5 places to fill. At each place we have 3 options. So number of strings in sigma power 5 will be 3 into 3 into 3 into 3 into 3, 3 power 5. Now according to the question, the language contains all strings of length less than or equal to 5, and we want to find number of strings of odd length. So if we consider length 1 or 3 or 5, the string length is odd. So to calculate the required answer, we should calculate sigma power 1, number of strings in sigma power 1 plus number of strings in sigma power 3 plus number of strings in sigma power 5. Now in this case, alphabet contains 3 symbols. Alphabet contains 3 symbols. So k equal to 3. And here to calculate the answer, it will be 3 power 1 plus 3 power 3 plus 3 power 5. Sigma power 1 contains 3 power 1 strings. Sigma power 3 contains 3 power 3 strings. Sigma power 5 contains 3 power 5, these many number of strings. So this is 3 plus 27 plus 243. So this is 273. So option D is correct option. Now complement of the language is calculated like this. Complement of language L is sigma star minus L. Now sigma star for any alphabet, sigma star is always infinite. And according to option A, language L is given as finite language. According to option A. Now from infinite set, if we remove some finite number of strings, we will always be left with infinite number of strings. From infinite number of strings, if you remove some finite number of strings, you will always be left with infinite number of strings. So option A is always correct. Now according to option B, if L is infinite, then complement of language is also infinite. Now can we disprove option B? Now if you consider alphabet equal to A and L equal to W such that W is even, so this is infinite language. So complement of the language will be W such that W is odd. This is also infinite language. So in this case, L is infinite, complement of the language also is infinite. Now if you consider language L equal to W such that length of W greater than 5. So this is infinite language. But if you in this case, if you consider complement of the language, then W is length of W less than or equal to 5. So in this case, complement of the language is finite. Length of W less than or equal to 5. So this is finite language. So option B is not always true. For a given infinite language, if the language is infinite, complement of the language can be infinite, it can be finite. So option B is not always true. Now option C and D, they are about reverse of the language. Now when we take reverse of the language, we simply take each string of the language, reverse it, and we get reverse of the language. So number of strings do not change. For a given language, when we calculate reverse of the language, number of strings do not change. So option C says if L is finite language, then reverse of the language is finite. So this option is also correct. Option D is if L is infinite language, then LR is also infinite language. This option is also correct. The reason is, for a given language, when we calculate reverse of the language, number of strings remain the same. So we have to check whether statement 1 and 2, they are true or false. So according to statement 1, there exists a language L such that L is subset of every language over given alphabet. If we consider language L equal to empty set or phi, then for any language over given alphabet, empty set will be subset of that language. So this statement is true. Empty language is subset of every language over given alphabet. And for statement 2, there exists a language L such that L is superset of every language over given alphabet. If we consider language L equal to sigma star, then sigma star contains all the strings, all strings of all lengths over given alphabet. So for any language, so if we consider sigma star will be superset of every language over given alphabet. So this statement is also true. Sigma star is the largest possible set. It contains all strings. It will be superset of every language over given alphabet. So both statements are true. So option A is correct answer.